Hello and welcome to your Unit 2 of Physical Geography. This one will be the Earth in Space. Again, as you know, okay, this will not change, will always be the same. I'm not going to play the videos that you see here, the links, but all the links are below in the description, so be sure to go and click on them because some of the questions I'm asking come from the answers will come from those videos, so be sure to watch them. So where is the Earth in space? Most of you should know our solar system and like the order of the planet, different different ways to remember it, right? Whatever it is. So just check and remember those, our solar system. This is a beautiful video, by the way, so be sure to go and look it up. And what are the main features that makes our planet unique in our solar system? What is the unique thing that the Earth has that we have not proved yet that there is on any other planet? If life comes to mind, yeah, you're right. That's one of them. Water also. Though now we have found water on Mercury. Yes, liquid water on Mercury. We found that. So it's really interesting to see that what actually makes the big difference on Earth is that we have life on it that we can prove. There's some indication about in Mars, but we haven't completely proved that yet. So we'll see. It's possible because there's an atmosphere, so you never know. Some go as far as linking the Earth in space to earthquakes. So if you click on the link here, it will lead you to a video from the barcaroller. It's a guy from Australia that links the earthquakes to different position of the sun and the planets and all that. Just look at his video. Just look at his video and then tell me what do you think about this theory? Do you think it's completely whacked, or is it possible? What is he presenting here? Is he presenting something that would actually have some scientific ground in it, or is it just circumstantial? I don't know. So just look it up. Well, I do know, but look it up, and we will be able to discuss that in class later on. Where do we start? Well, okay, let's start with the real beginning. So, what is the origin of the universe? That was and still is a hard question to answer, really, because we do not know for sure. There's many theories about it, but we definitely don't know for sure. There's four main theories that we will talk about here. There's way more than that. There's way more than that. But there's different theories. There's the ex nihilo, which says that it comes from nothingness. That is very interesting. The creation. So usually that is coming from a religion of some sort where a god created everything. There's the chaos from what we see on Earth. So whatever we see on Earth is how the Earth was, or the universe was created. And there's electric, or from a vibration, or also known as fractal universe. So those are the main four that we will go and look and discuss. So ex nihilo, from nothingness. Again, the links are below. Be sure to look this one up. This one, you might have to watch it a couple times to actually get the things, because the guy speaks a little bit fast, but he's explaining it very well. So that's something that you may have to look at a couple times before actually grasping the concept of what this means. Creations, so it's from God. So depending on the religion, you will have different explanations of how it's created. So there's no video. I'm not going into, because there's so many different religion talking about different gods doing different things as a creation, that I'm not going to pick one to go with, right? So that's the reason why I decided not to put any videos here. Chaos, so from what we see on Earth, so that explains it very well. And electrical or fractal universe, well, that comes from, there's a lot of different people, but Nassim Harriman is actually explaining it on the fractal universe side, and he's pretty good at that, and he's been peer reviewed and checked from all sides as far as science goes. So he's pretty solid with that theory. He's good at explaining it too. So be sure to look at the link below. So questions. Why do we say Earth is unique? Said that before. Name the 4 theories that we've seen about the creation of the universe. Just talked about them. And choose one of those 4 theories and explain why you think that one makes more sense to you. So remember, theories are never completely proven. So some theories make sense for some people and others for others. And it doesn't mean that if you don't think that one theory is, let's say you say, oh, this theory, I absolutely disagree with that theory, doesn't mean that it's wrong, doesn't mean that it's right. Does it just means that you don't see it the same way as they do, right? So that's why there's no right or wrong here, but the explanation is important. You have to explain why you think this one is better than others. And that's pretty much what I'm asking here. So let's organize all this. Okay, now that we have a few theories on where we come from, like the universe, how do we organize all this, right? Well, let's start with the obvious of what we can see, our solar system. That's another very, very nice little video here about our solar system. Again, you should know this. I think it starts something like grade 4 or 5, something like that, where we talk about the solar system. So we've talked about that multiple times. Now, the orbit of the Earth. The Earth is going around like this, right? Around the sun, we know this. And Galileo actually died for that, but he was right. The Earth orbit around the sun at over 100,000 kilometers per hour. So that's how fast we go. And it travels that amount of kilometers to complete the whole cycle, the whole orbit. Okay, so it's 929 million kilometers, something like it. And the Earth is at different places depending on if it's June, September, December, March, right? So that's how it is. Now, in the orbit, there's different things that you have to know. So the average distance of the Earth from the sun is about 150 million kilometers. So the average, why? Because it's not absolutely round. We don't go around the sun in a perfect circle. It's more like an oval light. So at one point, we are the furthest part, and one time we are the closest part. And as strange as it may seem, winter would happen here when we're the closest to the sun, and summer would happen when we are further from the sun. Why? Because of the tilt of the Earth. I'll see that later with you, but I just wanted to give you that little thing. Anyway, so this is not the point of this video here or this slide here. So how do you refer to the point of the orbit of the Earth when it's at the furthest from the sun? Aphelion. Perihelion is when it's the closest from the sun. The Earth is closest from the sun, right? And there's a difference between that and the moon has the same type of orbit as the Earth has around the sun, except that the moon is around the Earth, of course. And the perigee is when the moon is at its closest from the Earth, and the apogee is when it's actually the furthest from the Earth. Now, there's a lot of things, and I'm not going into details with this, but this is the reason why there's some time of the year where, or month even, where you have tides that are higher or lower than normal, because it's the closest, etc., etc. So I'm not going into this in detail. There's no point. I'm just going very briefly over the whole thing. And this is only for you to know the names and relate the names to the Earth or the moon. Okay? So those are, because this is a question, actually. Talking about questions, how many rocks planet do we have in our solar system? That's in the video if you don't know them. How many gas planet do we have in our solar system? Again, in the videos. What is between the rock planets and the gas planet? There's something there. So what's the difference between the apogee and the aphelion? And what's the difference between the perigee and the perihelion? Aha. Using the names. Earth movement and measure of location and time. Again, all those videos, link below. Be sure to watch them. So the progression of the seasons. So this explains a little bit more in detail why we have summer and winter and autumn and spring, right? So, and it's very well explained. So you don't need more than this really to understand it. And if you do, just ask questions in class and I'll be answering them for sure. Time and time zones, same thing here. Very well explained. This is a NASA one, if I remember well. Yeah, it is. And this is really, really, really well done to explain time and time zones. And the international dateline, aside from this kind of funny sound on the video, I'd say this is actually well done to explain where the international dateline is and how it works. So that's another one that is important for you to know. It's coming back in the exam and tests. You better know it. Just a hint. All right, so that's it for this one. Daylight saving time. In summer, we advance clocks temporarily. Why? Because afternoons have more daylight and morning have less. So there's more. So by exploiting the sunlight longer after working hours, it reduced the needs for of lighting once everyone has gone home. So that is main thing. It also promotes shopping and sporting activities. So it's not everywhere that is observing the daylight saving times. Every places that you see in blue, they do. If you see it in orange, those parts used to, but they don't anymore. They decided not to. And in the red, they've never observed that. And as you can see, most of it, of those that never observed the daylight changing time, they're pretty much at the equator, right? Except for a few here, but there. But I mean, in general, that's what it is, right? You've never observed it. So a quick review of terms here. What is the aphelion? It refers to the point of the Earth, whether it's the furthest from the sun. Aphelion is when the Earth is the closest. Apogee is when the moon is farther. The perigee is when the moon is closest. What is the axis? The axis is an imaginary line that goes through the center of the Earth, right? From North Pole to South Pole. It's 23 point something degrees. And I see by it's 23 something because it changes because the Earth is wobbling. So that's the reason why. Solstice is when the sun reaches the most northern summer in the northern hemisphere or southern winter position in the sky. So it's the longest or the shortest day of the year. So usually the longest day for us falls on or around the 21st, 22nd of June, and the shortest would be 21st, 22nd of December, around that area, depending. Equinox is twice a year, where the length of the day and night are the same in both hemispheres. And the sun is directly overhead at noon, like you've seen in the video. So the equinox is really when the length of the day are the same north, like on the northern hemisphere or southern hemisphere. So it's 12-12. The orbit is the path a space object takes to go around another space object. For example, the orbit of the Earth is around the sun takes 365.25 days. Yeah, it's not the exact 365 days. It's 23, yeah, 365.25 days. So that's why every 4 years we have to adjust and add 1 day, and then we call it a leap year, right? So that's where it comes from. That's why the leap year. It's because we don't go at a precise number of days. There's about a quarter of a day. So every 4 years, if not, we would have, I don't know, December and summer would not make sense, right? So that's the reason why we do this. We just add 1 day just to compensate for that. And here are our questions. There you go. Explain why we have 4 different seasons in Canada. It's going to be simple. If you watch a video, simple to explain. Why do we have 24 hours in a day on Earth? Another easy question if you watch the videos. Why do we have 365.25 days a year on Earth? Another easy one to explain. What is a time zone? From the video, easy to explain. What is daylight saving time? Why was daylight saving time started? Oh, and just so you know, it's a Canadian who actually started that. Is daylight saving time followed in every country? That is basically a yes or no question, right? It's easy. So there we go. This is the end of Unit 2, the Earth in Space. Thanks for watching. Take care. See you later.